VLPSos here. This is a video lesson for Python programming, proximity collision. This lesson file started as stub2. We're going to take a look at it running and then look at the code file to see how we accomplished it. Here we can see two circles bouncing around on a screen. Every frame we detect how close the circles are to each other. And if the circles are close enough, they collide. If the proximity of the circles is close enough, then we will affect a change to the circle. There's a color change every time the circles collide. And the colors seem to be flashing very quickly because the collision of the circles is detected once per frame. They often overlap or touch for many frames in a row. We're getting a color change each time. Let's take a look at the code file. First, the basics. We have a class called thing, and we make instances of thing in order to make circles on the screen. The important attributes for how we'll detect for collision are the X and Y position, which is the center location of the circle, and the size attribute, which is used as the radius of the circle. We make two instances and store them in a dictionary that we call population. We have an algorithm for moving them around on the screen. This is very similar to what we accomplished in the lessons in the past when it tracks horizontal and vertical movement independently, and when we get to the edge of the screen, it reverses the direction in those dimensions. Let's talk about collision. After we move the circles, they'll have a new position. And so once per frame, after we move the two circles, we check to see if in their new position they're colliding, which means the user sees that they're touching or overlapping in any way. Our idea, in order to accomplish that, because our shapes are circular, it's very easy to use this style of algorithm. The idea is that we have two circles that could be anywhere on the screen, and once per frame, we take the center locations, the 2 points which are the centers of each circle, and find the distance between those 2 points. We can do that with the Pythagorean theorem. Once we find the distance between the 2 points, we compare that to the sum of the radii. The circles will collide if the sum of the radii is greater than the distance between the two centers. Here in this picture, I have two circles which appear to not collide, which means that the distance between the two centers is greater than the sum of the radii of the circles. I've written a separate function that's a part of this code file in order to do that math and determine if the circles are colliding. Let's take a look at the code block in the frame loop. We iterate through the entire population of instances. In the beginning of the program, we only have two, but the program is capable of making more instances and seeing a whole bunch of circles fly around. So what we need to do is we need to iterate through all of the instances and then a second time through the same population of instances. We're getting two keys with these nested for loops. In other words, we're going to compare the position of every instance with every other instance. And those two instances have two different keys set up by these for loops. We call them key 1 and key 2. Now, once we have these two keys, we need to check that when we've selected two keys out of the dictionary, they're not the same because we don't want a circle to collide with itself. So once we have our two keys, we check that they are not equal. And if they're not equal, if they're indeed two different instances, then the next thing we do is we set up the information that we're going to send to this function, which will do the math to detect collision. The important variables that we'll send there are the points of the centers of the circle. I've defined them here as P1 and P2, the center points of the two circles. And then R1 and R2 are the radii of the two circles, which is simply the size attribute of the two instances that we're working with. Once we have those four variables, we send them to the find collision algorithm. And the find collision function will return true if it's determined that these two circles with their radii size and their center points are colliding. If the circles are colliding, then we choose randomly from a set of colors and reassign the color attribute to be different so that the user sees them change color or flash colors. Let's take a look at the find collision function. This was defined outside of the main function. The find collision function receives 2 points. There's tuple of 2s, an x and a y location, and 2 radii, which are integers. There are notes here that can be followed. What we're doing is the Pythagorean theorem to find the distance between those 2 points. Once we have that distance between the 2 points, in this case distance, we compare that with the sum of the radii. If that distance between the circle centers is less than the sum of the radii, then it must be that the circles are close enough to be touching or overlapping. If that's the case, then collision is true. If not, collision is false, and we return that Boolean value. So when we return true, it means that this algorithm has detected collision. And of course, that Boolean is sent back to where it was called, so that on condition of collision, we can get the changes that we've talked about. Let's see this again. And before we do, we'll point out that this program also has on the mouse click a Boolean called makeThing assigned to be true. And part of the frame loop has a way to make more instances with some random attributes, which includes reducing the size of the instances so that more of them can fit on the screen. Let's take a look. We can see our 2 large instances in the beginning. Now we have a better understanding of what is making them change color. I can press the mouse key to get more things, and I can keep on pressing it and observe that they get smaller to give more room, and only those that are flashing are the ones that are colliding with any other one. Remember that our algorithm required nested for loops to test whether the collision was happening between any 2 instances. So all of them are being paired up and checked every single frame. Now you have seen how proximity collision can be implemented by finding a function that finds the distance between the centers of 2 objects and uses it to determine if the objects are close enough to collide or interact. This method is especially good for objects that are circular or near circular. Use this code file as a stub. Make it so that a white circle is drawn with its center at the mouse location, so you can move that circle around with the mouse while the program runs. Make it so that any circle moving around that touches the white mouse circle is deleted from the dictionary. Have fun.